Good day, everyone. Now, in this video, we will be looking at collinear points. That is, the conditions that make points collinear, right? We will be going through the theorem which makes points collinear, such that even if there's actually no formula for this, right? So, we are going to try to get a concept. And when we are given any question, we are going to be applying this concept to determine if the points given are collinear or not. Now let's get straight back into action. Now, given a straight line, assuming this line were to be straight, as I said, assuming this line is straight, and given the point A, B, and C, right? Now these are vectors, right? A, B, and C. Now, assuming, not assuming, but taking the distance or the length of AB to be lambda, the length of BC to be mu, right? Now, from this diagram here, we can write the expression, the ratio of the length AB to the ratio of the length BC is equal to lambda on mu, right? Now, remember this expression AB is equal to OB minus OA, right? Now, let B and A be position vectors of A and B respectively, right? Normally, to represent vectors, we have to depend this B, or this sign can be made under it, or we can also represent vectors in the form B minus A, and take note, we bring a small arrow sign on top of it. It seems my writing is slanting, is going downwards, but let's take it that way. Now, as I said, this expression is equal to B minus A, right? So we can write this as B minus A, right? Multiplying multiplying mu, and this is equal to, right? We are cross multiplying over here, C minus B multiplying lambda. This multiplying mu and also C minus B multiplying lambda. All we are doing over here is that we are cross multiplying, right? Now, simplifying this expression, right? We get B mu, or mu B minus alpha mu, and this is equal to C lambda minus B mu. Usually the scalars are brought in front, but let's take this as it is. Now, factorizing or grouping like terms, we obtain B multiplying mu, this mu, and taking this to the other side, it becomes positive. So we obtain plus lambda minus alpha minus A mu minus C lambda, and this is equal to 0. Now, take note, everyone, take note. Can I have your attention over here? This is our first condition for points to be collinear, right? This is our first condition. Now, from this expression, we can derive that mu plus lambda minus mu minus lambda is equal to 0. Now, this is also our second expression. As I said earlier, we are going to be deriving two expressions for points to be collinear. There are actually more than two, but these are the two basic expressions for points to be collinear. Now, again, take note. We can replace mu plus lambda by, let's say, alpha, right? Let's replace this by alpha. and also negative mu. We can replace negative mu by beta, and also negative lambda by nu, right? So now this gives us the expression. Now let's bring the alpha in front, right? Alpha b plus beta a plus nu c, and this is equal to 0. Now all we've done here is that we've replaced alpha with mu plus lambda, and also beta with negative mu with beta, and also negative lambda over here with mu, right? Therefore we can also rewrite this expression as let's see, trying to get the color right. Okay, we can write this expression as alpha plus beta plus nu should be equal to 0. Now take note of this condition also. At least 2 of alpha or beta should not be equal to 0. So at most one of either alpha, beta, or nu can be 0, right? But not more than 2, or 2 should not be equal to 0. Take a minute to digest this, because this is very, very, very important. Now we have one last expression which we will be deriving, and I think that you are definitely familiar with. Now remember, we obtained two equations, the first being lambda plus mu plus nu being equal to 0, right? And also we obtain the expression lambda a plus mu b plus nu c is being equal to 0. Now take note, lambda, mu, nu are scalars. Okay, so someone can, or one can just replace lambda with alpha, mu with beta, and nu with any variable, even h, right? The fact that you define it as scalars, you are good to go, right? So now any term or any sign symbol for scalar can be used, preferably alphabet or symbols over here, as you can see over here, right? Now take note, making mu the subject in this expression, we obtain mu being equal to negative lambda plus nu, right? Making mu in this the subject in this equation. Now making mu be sorry, the subject in equation 2. This is equation 2, right? We obtain alpha a plus nu c, and this is equal to negative mu b. Now take note, mu is equal to negative lambda plus nu. It's like I'm talking too much, please bear with me. Lambda a plus nu c is equal to, now remember, we can replace this with lambda plus nu multiplying b, right? The vector b. We can divide by lambda plus nu, right? And we obtain the expression b being equal to lambda a plus nu c all on lambda plus nu. And this is the expression for internal division, right? This is the formula for internal division. And why have we derived this expression? Remember, if points are collinear, they lie on the same plane, right? If points are collinear, they lie on the same plane. And also internal division in internal divisions, if points are collinearly line on the same line, and internal division is used when points, of course, lie on the same line. And that's how we obtain this expression b being equal to lambda plus nu plus c being divided by the ratio between a and c respectively, right? Thank you for watching this video. We'll be solving more examples in subsequent videos, so please stay tuned. This is only the concept, and we'll be doing the interesting part, which is the application of the concept. This is Teach Me Maths. Please subscribe to be updated. Thank you very much. This is Teacher Ben. Voila. I don't know what I'm saying right now, but please subscribe.